Talk to you about AI agents. And as of making of this video, there's been more and more companies that are releasing their own AI agent products. Agent Force by Salesforce, Microsoft is diversifying their agent products, etc. And while I am of the personal opinion that AI agents are still not ready for prime time, these FANG companies are not of the same opinion, and they're releasing their technology as far as they've built it out to the public. So therefore, I want to make sure that everyone available that could possibly want this technology has access to this technology. For me, I'm kind of a bit of a dinosaur, right? I remember first hearing about the internet in seventh grade. I heard someone mention the information superhighway, and I was like, what the heck is this? And I wasn't alone in that. And then by eighth grade, I knew exactly what the internet was. That's how fast it caught on and how fast things changed. And I remember that. And so within those concepts, I remember the early days of the internet, and it was a much freer period and a period where you could do a lot more than you can now, actually, with the internet. I want to try to preserve that with AI as much as humanly possible. That's flat out my goal within all of this, right? And then so within that, there is once you understand the inner workings of AI, there's no inherent advantage that anyone, any individual, any institution, any company has when it comes to these things, just flat out. Right? If one person figures out how to crack these things, how to do this, then the entire world has access to that knowledge. And I think that's good. That's how this should operate and should maintain. And so I want that to continue. So I'm going to give you right now kind of this is the access to the world's knowledge that we have right now as it comes to agents. And up front, we haven't solved agents. Like, that's the bottom line, right? So the agent problem comes down to and is directly correlated to the generalizability problem. And what we have not solved for in AI is generalizability of AI. What I will say is that there is misconception and misdebate around this topic. To me, it's important to look at these things as scales as opposed to on-off switches. It's important to not say that AI cannot generalize, right? It's not an on-off switch. Let's say that generalization is a scale of 0 to 100, and human beings would not be anywhere near 100 on this scale. I think human beings would be about a 20, let's say. I think that AI is a 3 or a 4 or a 5 on the scale. And so it's definitely above a 0, far above a 0, right? Which is the most important concept within this. But what is the exact levers that we pull in order to get AI to move up this scale? We don't know that flat out, right? And I think the other thing that I'll mention before diving into this, kind of my framework and how I look at this overall, right? I think that a lot of people, they think about training AI wrong. They think about it as how a human learns, but I think that they misunderstand or mischaracterize how humans generally learn, right? We think of like human learning as someone going into a classroom and then they're being taught, etc., and that whole process, right? But that's not the beginning of learning. It's a little bit more, but it's the only way that I can know to break it down, and it's the way that I think about it in my head. There's an individual that I recently read about that they are like one of the first individuals to ever recover from locked-in syndrome, right? They had severe brain damage, and they were in a coma and locked-in syndrome for like a decade. And then the very first thing they were able to do was move their wrist. And then they were able to blink their eyes. And then it was more facial movement. And then able to construct words. But this is a months and years long process, right? Of relearning literally all of these things. And as this person had to relearn all of these things, it's again, months and years. It's not going into a classroom and then here's your ABCs and then tomorrow you know your ABCs, right? Like that's not human learning. Human learning is starting off with learning how to move your wrist, how to blink your eyes. We have to learn these things as babies, right? That's like we go through these processes and it takes a very long time. It's the same way with AI, and we don't specialize, right? But I I think we as people don't account for these things, and then so I just mentioned this off the top with AI because the bottom line is that it all comes down to generalization. And then so if you want to succeed within this, the bottom line is you want your model to generalize as little as possible. That's the goal within this, right? Is how do we set this process up so that we are doing as little like actual like thinking and work as possible. It's all laid out, it's all mapped out, and all of that work is done in advance. And then so I think that's the biggest misnomer that people have coming into this, right? Is that like they want to create an agent that is very generalizable. Whereas your end goal is that you're going to create 50 agents that are each very specialized. And then those 50 agents will then all come together to form your generalized tasks that you're looking for, as opposed to one generalized agent that does 50 tasks. You're not going to ever get that, right? So that's number one going into this. And then number two going into this, I think, is the number two most important concept to understand is that licensing and like how the software works matters more than anything else within this. And then so within these exercises, you'll notice that I'm utilizing very specific exercises, and that's that avoid licensing, and that's for a reason, right? Like if you want your agent to search the web and call and dump it into a Microsoft owned database or Microsoft owned product, then that's going to be a lot more intricate just because of the legalities and the expenses that are going to be involved with having to set up everything within those two steps, just those two things, right? Because you have to deal with optimization within that. Kind of goes back up to what I was saying up front, which is trying to keep all of this as open as possible, right? So within that, let's dive into exactly and how to create some agents, right? And then so up front, I'm utilizing a swarm-based agent framework. And then so if you're not familiar with swarm-based agents, this is literally OpenAI literally just released their own framework called Swarm that does it literally copies all of this, right? there's again, if you can do something with an AI, then you can do it. There's not differentiation, right? So if I can do it, OpenAI can do it. If OpenAI can do it, I can do it. Same thing, right? And so within this concept, it's the bottom line is that the LLM model alone isn't good. The LLM model alone is a mouth and a brain. And then so what is missing within that equation is a body. And then so the LLM model isn't equipped to execute action. It's equipped to think about action and to, of course, create and write out like natural language related to that action. So if we ask it to plan, it's good at that. If we ask it to actually execute the decision, it's bad at that. And then so within my particular framework, what I do is I just bolt on another form of AI called swarm algorithms that are very efficient at that particularly, right? Swarm algorithms are more like a body as opposed to anything else. And then the problem with swarm algorithms is that they lack a brain. And then so if you couple a brain and a mouth with swarm algorithms, which are a body, then you get a pretty cool and unique concept that allows us to, frankly, really do anything. So with this first example of this cat factor agent, what this agent is doing is it's calling this API call. It's making an API call to this Heroku cat facts, which is just a free cat facts thing that allows us to retrieve random cat facts. And then it's going to extract the data, and then it's going to put those into a notebook, right? And flat out, that's what it's going to do. It's going to extract 3 cat facts from this website. and then put them in a notebook. With a general, if you just have an LLM model do this general process, the LLM model is going to fail about 80% of the time, just flat out. And even if you're using a larger model, within this particular instance, I'm using the small LLM models, which are as small as it can get. And in this instance, I'm using a 135 million parameter model to be the brain for my swarm algorithm. So you could run this on a calculator, essentially. And then it's very straightforward as to what this does is, again, it's just making this API call and then going through and retrieving those facts. Within this, what you'll see is my architecture is very straightforward, right? I have, it's all swarm algorithms, so I have a swarm brain, and then the brain is responsible for making decisions, and then the way that the brain makes decisions is in a very specific response format, which is based off of action, reason, and parameters. And then so it will always output its response as action, reason, and parameters. And then it's going to respond to output each of these in JSON-L format. And then that's essentially what it does in that instance. And then we have our individual agents, right? So define the agent, and then in this instance, define what the job of the agent is. So in this instance, the job of the agent is to be a cat fact collector. And so it is to get cat facts, and then it is to save those facts to the notepad. So its job is defined. The body's job is defined, and the brain knows what the body is supposed to do. And then so if the body runs into any problems, then the brain tells the body and helps the body out in this instance. And then so the body goes, makes the API call, and then in this instance, it looks for success status code of 200. If it gets anything other than a status code of 200, then it asks and it prompts the LLM model, what do I do from here? And then the LLM model corrects it and then sends back instructions to the swarm. Very straightforward, right? Second example that we're going to go over is called board agent. And then so it's kind of like a similar concept. So what we're doing is we're making an API call to a different API in this instance to show you that it doesn't have to be the specific one that we're using there. It's going to retrieve information from that API, and then it's going to summarize the information that it retrieves from that API. And then so again, you can see it's just it's the same type of process, right? I create a swarm brain class. So I create the brain. Here's your instructions. And the brain is all related to the LM, right? This is all the LM. Your job in this instance is to create your decision and then to generate an essay as well. So you need further instructions for generating an essay. So here's your instructions there. Same thing below. You have your swarm agent and activity collector. So same as before, right? Here's exactly what your job is in this instance. You go through, perform your functions, and then return those. And then the last example that we have here is our multi-agent story generator. So this is like multiple agents working together, and then they're telling a story, right? So one agent will tell one sentence of the story, and then the other agent will add on, and then boom, 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 add in sequence, right? The thing with this one is that this one takes a long time to run. So I'm not going to run this one for you in real time. I'll run the first two for you and show you exactly how they work, but I'll show you an example output of our story generator here. And then here's all of the code for you saved in this Colab notebook. I'm not going to execute it from the Colab notebook. I've made this just for you with a link to this description. If you want to review all the code that we're going to go over in this video here today, here it is all for you in this notebook. So with that being said, let's dive in and then let's launch and see exactly what these do, right? So the very first thing that we'll do is we'll utilize our cat factor agent. And then so you see here, I've actually got these Python files saved here. So I've got cat factor, which is I literally just copied and pasted over the code here. And then I'm running this in a virtual environment, this breakout virtual environment. So I just hit catfactor.py. And then it's executing, making the API call, and then catfacts saved to this document that it just saved to. So then I'll go to my folder here. Recents is what I want. It's kind of what I was hoping for. There we go. And it saved it to CapFax is the name of the folder. It's not that one. So break it. Cancel it. Sorry guys, give me 1 second. I know where it'll be. There we go. And there we go. CapFax. One, cats do not think that they're little people. They think that they're big cats. This influences their behavior in many ways. Two, the Maine Coon is 4 to 5 times larger than the Singapura, the smallest breed of cat. And three, cats have individual preferences for scratching surfaces and angles. Some are horizontal scratchers, while others exercise their claws vertically. So very straightforward here, right? So simplistically, we just had our agent make an API call, collect the data from the API call, and then generate and put that into a notepad, save the notepad, and then here we are just reading from the notepad. Very simple, right? Next thing that I'll run is this board.py. And this one's going to take about a minute or so to run because it's going to do the same thing, but then it's going to do one extra step, which is it's going to call the LLM model in this instance. And then the LLM model is going to write a summary based off of all of the data collected. So in that first instance, it didn't end up having to call the LLM model because it ended up executing successfully off of the bat. So there was no load, which allowed it to load extremely quickly and then go through and come in, whereas in this instance, we're having to load, communicate with the model. The model is having to produce its output, generate its tokens, and then it has to go through that same process, right? Saving the file, and then it just did activities and essay saved to an activities file. And so I go here. This is the latest one, activities from today. Boom. Suggested activities. 1, organize your movie collection. 2, write a list of things that you're grateful for. 3, play basketball game with a group of friends. So this is what it pulled from the API. And then the model generates an essay based off of that. Write a short essay about the following activities and their potential benefits. Here are some interesting activities to try. And then it relists what it gets. And then so this model is a very small model, right? I'm utilizing this model in particular for demo purposes in this instance. Highlighting here in this instance, it's very simple to change the model that we're using here, right? So these small LLM models, this is the biggest one of the small LLMs. And then so you'll notice here it's just small LLM 2-1.7b. So then if I just go here and then if I just replace and I put 1.7b, it's going to be the small LLM 1.7b, which would be a lot more powerful than the models that I'm showcasing here, but they would take a lot longer to load, to execute, things like that. And so I'm just, for simplicity's sake, I'm showing you on the most basic models. And to me, it's like, again, it's always super cool that I can actually do these things, right? Like you can actually execute and run agents and then have your agents running and your brain of your agent being 135 million parameters. Like you don't have to make it higher. And then so to me, that's cool that you don't have to actually make it any higher or like beyond that, right? like why would you want to? You don't need to. So just cool from there. And then so the last instance again is the storyteller. And then so I don't want like it takes like 5 minutes for it to go through, but this is a story that was generated from the storyteller. So shadows in the forest. What are the main characters? How do they interact with each other? Why do they think the author chose to include them in this story? And then you'll notice the model goes through and then prompts itself to think through this, right? Like it's like this setup is set up so that this model acts like GPT-01, right? Like that same type of concept, same type of logic. You can do that. You can do that with your agents. And that's what I'm trying to end with this, right? Like everything that you see with agents coming out from these companies, from Anthropic, from OpenAI, et cetera, it's super cool what you can do with these agent models, but just know you're not locked into utilizing their technology for it. You're not locked into paying them for it. You can do it, especially if you have simple tasks. You can utilize these very small models to execute and run your agentic tasks for free. And then the bottom line is, again, remember that you're not setting up one agent. You never, even if you're utilizing Claude, right? You're never going to set up one agent to do to rule them all. It's going to be agents for individual tasks. And then so in that instance, if you can have 135 million parameter model as opposed to Claude do it and pay free as opposed to paying per API call, why not? And then so in this instance, there's literally no downside to this. It's just learning some Python code, getting out there and running it. And so hopefully this gives you the impetus to get started on that if you're in that boat. And if you like this type of content, please like and subscribe. Thank you very much.